Alright, so in this example, we try to find the Laplace transform of this function square root of t by just using the list of the, what was that, the Laplace transform table, right? So that we have the Laplace transform table, so we just want to use couple of properties of the formula from there and then figure out the Laplace transform of this function. By looking into this function over here, it seems like we have the radical sign, so square root of t, but that can be changed into the exponent. So square root of t means something like t to the power 1/2, right? So if that is the case, what formula do you think would be useful over here from the Laplace transform table? So if you look into the table, you can see there is at least one of them is like if you have t to the power a, right? So the Laplace transform of that is actually the gamma function, right? So gamma of a plus 1 divided by, let's say, s to the power a plus 1. So that's the formula we have, and then I think we can use that over here to figure out the Laplace transform of this given function square root of t. So if you look into here and then compare this power here 1/2 with a, right? So we can see that in the power the value of the a would be 1/2. So if that is the case, we can plug that exactly 1/2 over here on this formula. So applying in that way, then the Laplace transform of this given function t to the power 1/2 should be gamma of 1/2 plus 1, right? So that's what we need to have it, and then underneath that s to the power 1/2 plus 1. So this should be that's your Laplace transform of square root of t. But the next question is, what is that gamma of 1/2 plus 1? So can we simplify that? And then for that, we need to know a couple of properties of the gamma function. One of them is the gamma function. If we have gamma of, let's say, n plus 1, something like that, this can be written as n times gamma of n. So this is how we can write down. So if that is the case, we can look into here. We have what, 1/2 plus 1, so 1/2 plus 1, something like that. So n is 1/2 with by using that, then gamma of 1/2 plus 1 can be written then as 1/2 of gamma of 1/2, right? So by comparing with this formula over here, so this is how we can write down. Underneath that we have s to the power 1/2 plus 1 is 3/2. But still, do we know what is gamma of 1/2? Because we know what is 1/2, but do we know what is gamma of 1/2? For that, there is also another property, which is if we have gamma of 1/2, this is actually equal to square root of pi. So that's the value of the gamma function at 1/2. So if that is the case, now our job is much more simpler, because gamma of 1/2, we can just copy that value over here, right? So if by using that, then we'll have 1/2 square root of pi. That's it, right? So and then divided by s to the power 3/2, and that should be it for the Laplace transform of the given function square root of t, and then which is over here. All right. So with the similar kind of, let's say, formulation, for example, let's say if our goal is to figure out what is the Laplace transform of, let's say, t to the power 3/2, then what should be the answer here? So the Laplace transform of t to the power 3/2, again by using the same formula here, this can be written as gamma of 3/2 plus 1, right? And then underneath there we'll have s to the power 3/2 plus 1. So that's what we have. So at the bottom we'll have s to the power 3/2 plus 1 is actually 5/2, right? So we can, that's how we can combine. But at the top we have gamma of 3/2 plus 1, and then using this property, this can be written as okay, so let's try to work somewhere else over here. What is gamma of 3/2 plus 1? So gamma of 3/2 plus 1, by using this property, we can write down that as 3/2 times gamma of 3/2, right? But as you know, 3/2 mean actually 3/2 means 1/2 plus 1, right? So 3/2 means, so if that is the case, if you want, you can further break down that gamma of 3/2 as 1/2 of gamma of 1/2 by using the same property again. So same property over here. And then now if you write down in that way, now we know what is gamma of 1/2, right? Gamma of 1/2 is square root of pi. So if that is the case, 3/2 times 1/2 times square root of pi. Right, so in this way, by using kind of the reduction of this, let's say gamma, this reduction properties of the gamma function, we can actually come up with this value over here, which is 3 square root of pi divided by 4. So 3 over 4 times square root of pi, and that's exactly the value we can write down over here. And then that should be it. This should be our Laplace transform of the 3 to the t to the power 3 half. Alright, so that was just the extra example we were working on, but our problem was to figure out the Laplace transform of square root of t, which we have figured out already over here, right? So 1 half square root of pi divided by s to the power 3 half.